Just a brief background of the project, the commercial project we are about to launch in Western Australia. Our company, EcoMag, is actually a startup company, a new breed actually, to basically recover magnesium from a waste bitten rejected by solar salts operations in Western Australia. That slide there shows you basically the discharge channel of the bitten. The bitten is actually a waste after you solar evaporate the seawater. After about 2 years, for example, you ended up with sodium chloride salt, but then you reject about 5% magnesium in the bitten, which is basically rejected back to the sea. What we are doing is basically to develop technology over the last 4 or 5 years since the establishment of the company in 2015-16 in order to recover this magnesium and then process that to high purity products. Magnesium production is not new in Australia. We have several mines in Australia here producing magnesium carbonate minerals, but then it's a low grade material. That material is only 85 to say 90% grade. Here we are able to recover magnesium, from 5% in the bitten, in the brine here, and we can produce up to 99% plus high purity materials. In Western Australia, it's the largest production. We have the largest production of solar salt every year, and when the existing companies, we have 3 or 4 companies there in the West, are producing something like 14 million tons of sodium chloride salt. And we're working with one company here, one salt field here in Karratha in the Dampier area. And that plant alone produces something like 4 million tons of sodium chloride salt. And then it rejected almost the same amount, 4 million cubic meter, 4 million tons of bittens. And of that, you have 5% of the magnesium in the content. So what we're trying to do is we have conventional technologies to recover magnesium by chemical techniques like precipitation, and then we filter it to recover the magnesium products, magnesium carbonate we produce, and then we go through filtration to recover the product. Then we dry, and then we will crush it and grind it, and then bag it into products. But we are aware of a technique used mainly in pharmaceutical production or in food production, like spray drying. And this is what we're trying to test this technology here with the experts at University of New South Wales and the CRC group. So just a quick and a very brief introduction of the company. We are a specialist group trying to recover magnesium as a purest magnesium specialty chemicals, 99% pure products we can produce. And because the magnesium is recovered as from a waste, it actually has a very low carbon footprint, and we actually have the lowest carbon footprint products, magnesium carbonate, magnesium oxide, etc., compared to existing products on the market right now. And more importantly, also because it's coming from a waste, it's actually a natural product, and we have organic certified from the Australian Organic certification. And with that, we are ahead of the competitors already. The company is committed to, as you know, circular economy and ESG principles, which are now promoted mostly by companies in Australia. Just a quick introduction of the project. It's in Dampier. Dampier is about 2,200 kilometers north of Perth. So to fly from Perth to Dampier would take you almost nearly 2 hours on the plane. We are located near the Karratha airport. Karratha is a town, is a city actually of the Dampier region, and it has 20,000 people in that town, in that city. We are located at the top end here of the Karratha airport, and you can see here, if you can see the white squares, they are basically the area belonging to Dampier Salt Limited. That's the company making salt, and then they reject the bitten, which is a waste brine, to the sea through the channel I showed you earlier. The place is near the port as well, so in terms of setting up a plan and setting up production, it's quite useful to leave and to have it near the port. Karratha is also, it has the largest port for iron ore and salt export, but we also have facilities there through another port, through Dampier port, to import smaller quantities into via containers. So it just quickly to go through some of this here, and I won't stay in this for long, but I'll just quickly introduce to you the market of magnesium. It's most of the time, it's 90% maximum for minerals, but for the high-grade synthetic inorganic magnesium products, 98% or higher, these are the inorganic salts normally used in food, as food additives, as fire retardants, as well as in various applications, in pharmaceutical ingredients, for example. The price range for those products I mentioned there briefly, about $2,000 per ton maximum, and the market size is about 1 million tons per year. We're also making the material here, covering magnesium carbonate, magnesium oxide, magnesium hydroxide, in that sort of suite of products we can make. We can also making some of these very highly high purity, up to 99% or higher of the magnesium products, and these are the organic salts or chelates we call, used as pharmaceutical ingredients. The citrate, gluconate, glycinate, you've probably seen most of these used in food as well as in magnesium supplements. The market is very big for us. Hopefully we can get into the market here, $1.5 billion a year, and with that, hopefully there's enough room for us to get in. So just a quick show here of how we get into the production. We started with the bitumen from the brine, of course, and then we can make magnesium carbonate first, and then from there we make magnesium oxide, magnesium hydroxide. We can then go to these are the phases we're going through in terms of commercialization. We can from there make pharmaceutical and food grade MgO and magnesium organics, as I mentioned earlier. In phase 3, we will change the process a little bit in order to make low carbon magnesium oxide and magnesium hydroxide. So that's basically briefly the plan for us to get into production through 3 phases. What I like to talk about our project here at the university with Cordelia is that if you look at the flow sheet here, this is how we make our magnesium organics and magnesium, from the magnesium carbonate or magnesium oxide from the plant in Western Australia. So the idea is we have 2 production plans. The first one in Karratha at the resource site, we're making, say, up to a maximum of about 50,000 tons of magnesium carbonate. Some of that will be converted to magnesium oxide or magnesium hydroxide, and a percentage of that is also transferred back to Sydney, to New South Wales, where we are going to build a organic magnesium plant in order to make all these magnesium organic products. There are 14 or 15 products we can make, citrate, lactate, gluconate, for example, and that's the aim for the next 5 years or so, when we hopefully will convert the material into the available products, both in Karratha and hopefully in Sydney here as well. So we go through, as I mentioned earlier, the conventional technique of waste bitumen converted to, the magnesium from waste converted to magnesium carbonate using precipitation, and then we filter that material in order to get a solid. Then for organic production, we have to redissolve it back, like magnesium citrate solution or magnesium gluconate solution. And then conventional technique is that we have to crystallize that material, by either evaporation or by vacuum crystallization. And then we again filter it in order to get the wet organic salt. We dry it and then we pulverize that to get the magnesium organic products. But if we can apply the technique mainly used in food production as well as in pharmaceutical production, we can just using spray drying technique, and we feed the magnesium organic solution directly into the spray dryer, and then that will hopefully help the cut down the time as well as the number of units we need to use in our production plant. So if on the right hand side, I will show you the conventional rotary drying we normally use. So It's basically like a tube rotating about 10 to 20 RPM, and then you fire at one end in order to create a gas at about 200 to say 300 degrees C, and then you feed your material in to that rotating drum, and then you hopefully it will be dried, and then you can recover the dry product. So even in the drying unit here, you can see conventionally you have to have many unit operations there in terms of the operation of the burner, and then to heat it up the gas and using that gas to dry the products. But with the spray drying, as an example here, what we could do is we can actually get the solution. We made it from the solution of magnesium oxide or magnesium carbonate into using the organic acids, and then we just spray dry, and using the hot air to basically dry that material almost within seconds in that drying chamber. So that technique has been tested, has been used quite extensively in the pharmaceutical and food industry. So we're trying to bring it into here. We have one unit at the university, which is a pilot unit, and we are trying to buy almost the same unit here for our lab facilities up at Cheswood, and but we need to learn more about this technology here before we can actually build a bigger one on site. So we have one of our research chemists working at the university as well, 2 or 3 days, 2 days per week, and then we show you that basically the kind of support and research we could get from the university. We're making magnesium citrate, glycinate, fumarate, and gluconate in our first year, and I think the first year will basically be completed in December, and then we still have 1 more year to go for this particular program. So we use all the facilities at university, the SEM, for example, with the analytical techniques. We actually can use that at the university as well. We have our facility at Cheswood as well. Our purity, I can show you there quickly. We can make 99.5% or higher products. So these basically in stage 2 next year, we're trying to look into the spraying of magnesium hydroxide as well, and hopefully with that we can actually improve the unit operations even further without having to go through conventional techniques on several stages to make dry magnesium hydroxide powder. So with that, I'll conclude my presentation here.